Greetings to all. I'm Priyanka Suri. I'm a research scholar in Center for Nanoscience and Engineering at IISc, and I'm here to talk about my research. Before I start, a little background. Advent of electronic devices has made our lives better, faster, and easier. Consider computers. A computer processor is made of transistors, which is an electronically controlled switch. The size of these transistors decides the speed of computers. Their number decides computation power. Modern day transistors are just a few atoms thick. To give a perspective, we can fit more than 10 million of these on tip of a needle. However, we are approaching the physical limit of reduction in size of these transistors. Below this, the transistor will never be off. As we cannot keep reducing the size of these to make them faster, we have to find alternative ways for faster and powerful computation. Speed of computation is limited by speed of electrons in the transistor. What if we could replace electrons with something much faster? What is the fastest object we know of? The answer is light. For reference, the theoretical speed limit of electrons in silicon is 10 raised to the power 5 meter per second, and we are nowhere closer to this. Speed of photons, you ask? 10 raised to the power 8 meter per second, a clear 1000 times jump in computation speed. So if an electron is a bullock cart, a photon is faster than a fighter jet. Basically, we go from electronic computing to optical computing. I derive my research motivation from this. One of the biggest challenges in optical computing, however, is to procure a photon on demand. Well, any material at its atomic level can act as a source of photons. When triggered, photons come out from any point in space and at random times. What we want is, however, to control when and where these photons come out from. We use nanotechnology to achieve this. In my research, I use a sheet of atoms instead of bulk to reduce the randomness of photons in space. I engineer nanojunctions by sandwiching the sheet of atoms between metal nanoparticles like gold and silver. These nanojunctions then act as pressure points to the material and create hotspots such that the photons come only from these exit points when triggered. To summarize, I have engineered a controlled source of on-demand single photons at nanoscale, taking us a step closer to light speed computing. Thank you.